Okay, back again. Now it seems that everything is working, and we were at the point that I wanted to just start what we have done so far, looking at theoretical models. And well, we started with a Keynesian commodity market. And what was the main assumptions which we made? Well, we had a demand side view. We had, of course, only commodity market and, very important, fixed prices. And this was just this picture. And then we calculated with the condition yd equals y, the equilibrium in our economy. Then we said, well, in practice, in a developed economy, we have not a pure exchange economy, but we have some medium for exchange, that everything becomes much easier, and this is the central medium of exchange is money. Of course, if we want to describe a modern economy, we also have to deal with money, and this was then the ISLM model. And there, again, demand view, now commodity plus money market, but still fixed prices. And then we had the so-called ISLM model with the interest rate and income equilibrium. Well, of course, if we talk about an economy, then we quite often talk about prices and that prices are changing. And therefore, of course, we need a model where we can change prices. And this was then the ASAD model. And there we, I say, introduced also supply view. This was motivating the AS curve. And now we have partially flexible prices. Still remember that we derived the AS curve, that we said we had some rigidities in the labor market or in the commodity market, or that we have some that we have some mistakes in expectations about prices. So prices are not still fully flexible. But also we then tend to the so-called long-term AS curve, and in this case we then had flexible prices. and this was this diagram. P, Y, the short medium run AS curve, AD curve from the ISLM model, and then the long run AS curve, and this was then the equilibrium in our economy. And this part here of a long-term AS curve, here we want to have a deeper look. Where does this view comes from? And this is the so-called neoclassical model. What are the main assumptions of this neoclassical model? Well, of course, we say that only real variables define the wealth in economy. Remember there, the classical dichotomy for the theory, quantity theory of money. There we also motivated that we have a split between nominal and real variables, and in the end we are not interesting, do I earn €1 million or something like this? I'm interesting, what can I buy with €1 million? Or also compare the Fisher relation. Nominal and real interest rates. So we are not interested in the end, I obtain 7% for my investment. I'm interested, after I've invested and I have a yield of 7%, what can I buy with this yield in the end? There we also subtracted the inflation rate. So we are look now only at real variables. And also we look at the free market process. So our general price quantity diagram. There we always argue that if we are out of equilibrium, that then always prices can adjust. But of course, that you have the possibility that prices can adjust, then you really need a free market. And for this, of course, in general, you need a free trade economy. Well, and then we can also go into political theory. In the end, this means you need to have a democracy. Because otherwise, you always have somebody who says, well, no, I'm delivering no energy. No way, no matter what you are paying. So behind these assumptions of totally flexible prices, we need this free trade economy. And how should it work in the end, that you have free people, that you have people who can really decide? And this is connected with these first assumptions. Then money is primarily only a medium of exchange and no source of wealth. I don't know, ask your parents or your grandparents when they traveled on holidays to Italy. Then we had there the currency lira, and in the 70s, in the 80s, roughly 1,000 lira were 1 Deutschmark. So everybody in Italy was a millionaire. But of course, you wouldn't say that everybody was wealthy people. And then, well, this we always assume in economic theory that in general enterprises are profit maximizers and that individual are utility maximizers and that we are dealing with fully competitive markets. So not only the possibility of price adjustment, but also that prices can really very fast adjust. Well, and if we have this very fast price adjustment, then of course we can say if this process is so fast that we are more or less always in equilibrium. Well, and then I talked so much about it. Of course, all these assumptions only work if you have flexible prices. Well, and then if you are always in equilibrium, then what is produced is determined by your ability to produce, by the framework, by the infrastructure of the economy. And therefore now we are more or less switching to the supply side view. And for this, we have to define what do we understand by production. And now there comes some mathematics. But I hope that I also can motivate that it is not nothing highly complicated, because again, we just want mathematically to describe what we find in reality. And we have this macro view, so we have a look at aggregated variables. And then we say, in general, we have more or less 2, maybe 3 production factors. And one is, of course, labor. That are we are working. And we have capital. These are our machines. Compare this when we have these different views on GDP. There we also looked at capital income and labor income. And then, of course, now we are looking at the framework of the general situation in which an economy is. And this we want to model with another parameter, and this is then called technology. Well, and for this general variable, we make a very simple assumption, because we assume that we can take out this variable just outside the mathematical function, so to speak. Or we make a very simple mathematical assumption, and this assumption is that we take this framework parameter, this technology parameter, and say just this is a number, and with this number we multiply the production function. So you can think of, if you have a developing country, then you say maybe this parameter A is 1, then multiplying 1 by specific conditions for capital and for labor, and then you take a developed country and like Germany, like the United States, and there, because we are highly developed, then this parameter is maybe 3, 4, 5, 6. And then we make these assumptions here for the dependence of production on capital and labor. And the first two are very simple. This just means the more input, the more output. First derivative positive means monotonically increasing function. The more input, the more output. And then we assume that the second derivative is less than 0. And what does this mean? The second derivative is the first derivative of the first derivative. So, and translated, this in monotonicity means that the first derivative is a decreasing function, because the first derivative of the first derivative is negative. And if you have a function where the first derivative is negative, then this means it is decreasing. So what does this mean? This means that the increase, the more output here, which is always added if you hire the first worker, the second, the third, the fourth, and so on, that this increase of production is decreasing. So if you hire the first worker, your production is highly increasing. Maybe from 1 to 10. If you hire the second worker, still your production is increasing, but less than compared to the hiring of the first worker. So in the first, from 1 to 10, and the second worker then maybe from 10 to 15. The third worker, again, you get more output, but what you are adding is less than before. So then 1 to 10 to 15 to 18 and so on and so on. And well, where does this assumption comes from? Well, also just when we look outside. We say if we start production, then we are quite fast in increasing the output. But then production processes become more complicated and more complicated and more complicated. And in general, on our average, then it is by just looking how we produce a quite good assumption that in general it will be harder and harder and harder to get to add something when you are already in a high level. And also if you look at the data, economic growth rate, if you look at developing countries, then you have their growth rates of 3, 4, 5, 6, 7%. Or look at China in the first decade of the new millennium, from 2000 to 2010. During this time, China had growth rates of 10, 12%. Or look at Germany. Well, this maybe I show it you also. But Germany directly after World War II. This was the first Wirtschaftswunder. There, Western Germany had growth rates also 2 digits, 10% in the 50s. But because why? Everything was destroyed. So we come from a very low production level, and then it was quite easy to get a high growth rate. And if you look at growth rates in developed countries, then at the magic square, just remember we are quite heavy when we are growing this 2%. So we can argue that this is a good assumption. And we also see this in the data. And then we make the assumptions of constant returns to scale. And this you have to distinguish from looking at the first and the second derivative. Be careful at that point, because quite often we mix this up. When we look at the partial derivatives, then we look always only at one input factor. Ceteris paribus, we set the other input factor constant. In this case here, we only look at the change of capital. We don't care about what happens with labor. And now we look simultaneously at a change of both production factors. And this is meant here by the factor lambda. Think of lambda is 1, 2, or 3. Or think of lambda is 2. What does it mean? This means doubling both input factors. And now we make a very strong assumption about the case. What happens to production when we are doubling the input factors? Then we make the assumption that we can just, similar to this assumption here on the technology parameter, that we can just take this parameter outside the production function and we just multiply with this number. So this means doubling both input factor means doubling output. And this is, of course, a very, very strong assumption. I think you have had some business administration courses, and there the other lecturers, they tell you, well, we are always looking at management decisions where we can find production conditions where we get more outside when we are hiring from the next, when we are doubling our input, that we want to have more than double output. Or if you look at mergers and acquisitions, what is always the argumentation? Well, we can join some parts of the two companies which we want to merge. And well, think of that in the two separate companies. In these two parts, everywhere were 100 people working. And then the idea of the merger is that afterwards, if you join this part of both companies, that you maybe only need 150 people in producing the same output as before. So in general, we are always looking at increasing returns to scale. So, but why do we make in macroeconomics this very strong assumption that we do not have increasing returns to scale? Have you talked about this in other lectures? Because you almost always then find in one sentence, if you look in a book or something, there then always, well, our production function exhibits a constant returns to scale. You have talked about returns to scale? I think so, yeah. Now, this we won't do here, but I have written it down here, the so-called Euler Theorem. From this mathematical assumption or condition, maybe you can try it if you just derive this function then not with respect to L or K, but with respect to lambda, then you can show that the production function can be rewritten as marginal product of the factor times the factor itself and summing up all marginal products times the factor itself. So, and what does this mean? Where do we find also in the production side, in the supply side, the marginal production factors of the input factors? Well, think of profits. Profit is just prices times quantity. So, or here I said Y for the production, sorry. So P times Y. And Y depends on K and L minus costs. So this is revenue. And these are costs. And costs is wages times labor input minus interest rates times capital input. Okay, this you, I think, also have already seen. So this is just costs. What do you have to do when you want to maximize profits? Well, you have to take the derivatives. And what does this mean? Profit is quite often written as pi. The pi with respect to k means we are in a fully competitive situation, so we have to take prices as given. Prices times the derivative of production with respect to k. Then labor is for us just a number. And I times k, first derivative, we have only I. This has to be 0. Maximizing. So in optimum, we just have the marginal product of capital is interest rates divided by prices. So, and this is of course real interest rates. So here we also have this marginal product. And this means if you have constant returns to scale, that in optimum, in maximum, you have 0 profits. This means in optimum, we have profits equal to 0. So pi star equals 0. And maybe this is quite surprising. So we write down a model, and in this model, there we make assumptions which mean that our enterprises make no profits. Have you talked about this? Why we make the assumption in general that firms make no profits? Yep. Yes, great. And what is then the qualitative argumentation behind this? That if we have fully competitive markets, that then we could not do better than zero profits. Yeah. Mm-hmm. Mm-hmm. Okay. Yeah. This is part of the explanation. And also you can think of what is behind fully competitive markets. This also means, and I think this you meant, that we have many, many demanders and we have many, many suppliers. And this is also because why this price adjustment process function. Because if I have many firms and there's one firm with a lower price in the market, then all demanders run to this firm. So, and this would mean then in general, if we assume that there would be positive profits, what can happen? Well, there is an incentive for new firms to join this market and to also get a slice from the cake. And there's always an incentive if you have a positive number for profits. Then always somebody is joining this market. And this then dampens your profits via the price process until zero. So this may be at a first point surprising assumption, is totally explainable when you assume that you have fully competitive markets. And this is the reason that you then in one sentence always read, well, in general, we assume constant returns to scale. But this doesn't mean that if you are ready with your studies, that you go to an enterprise and that you are looking at parts for some production processes where you have increasing returns to scale. So this is, of course, then for some time, it will be, of course, sometime possible to have increasing returns to scale. But then also neoclassical view means long term. And in the long term, then we assume that all these possibilities vanish. And then maybe you have seen this in other lectures, is I gave you here the standard production functions. When you have a look in a book, you will find them. This is, of course, at first the linear production function. What kind of inputs stay behind the linear function? Yes, of course. Here always capital and labor. And technology is always the thing. But what is, so to speak, the dependence between these production factors when you have a linear production function? I don't know, maybe you have seen this when you looked at the production side in microeconomics. There, I hope that you have talked about the so-called isoquants. And how does an isoquant of a linear function look like? Well, if it's linear, then it's linear. So it's just a straight line, and a straight line for two production functions, and the isoquant means that I just can directly exchange these input factors. If I increase one input factor by 3 and I decrease the other input factor by 3, then I have the same level of production. So these are perfect substitutes. And this Leontief function, I think you also have talked about this. This min function. These were these kinked isograms. You have seen this? And then, not perfect substitutes, but yes. Well, and these all, of course, are the extreme cases. And then we say we have also to have something in medium. And this is then here our evil Cobb-Douglas function. I think this function you also have already seen with factor 1/3, 2/3, I don't know. Well, and then there is a very famous paper written, I think, by 4 economists, I think in 1965. Maybe I put you the link in Moodle. And 3 of these guys, do I find this here? Maybe. Let me see, MS paper. (1961). There it is. Where is it? Where is it? This one. Is it this paper? No. So, well, I didn't directly get the PDF version, but Kenneth Arrow, Nobel Prize, and Robert Solow, also Nobel Prize. And I put the link here. If you have a look in the internet, you will find this paper. So then you can click on it. Well, in this case, they asked the general question, which function would exhibit constant elasticities of substitution? So that the exchange of both input factors relatively would be constant. And well, they did really yeah, very, very long calculations. And in this case, I think that they have done this. The reason is that they couldn't speak German. Because, well, they did their calculation, everything is right, what they did. And then they found this function here. And this is then called the so-called constant elasticity of substitution function. And this is maybe the quantitative workhorse of production functions. So if you want to model production, then really often you use this kind of a function here, because it is a very general function, and actually this function is 250 years old. Because this is just a general mean. Because if you insert here 1 for delta, if you take 1 for delta, then of course you have the linear case. Then you can show that you get the Leontief case if you take delta running to infinity. And what you also can do is, if you take the limit of delta equals 0, you can show that this function is just the Cobb-Douglas function. And actually, if you look at the Cobb-Douglas function here, and let's take alpha equals 1/2, then you get y is square root of capital and labor. And what is square root of capital and labor? This is nothing else than the geometric mean of these two numbers. So, a bit long at this part, but I think you should have seen, if you're studying economics, this function. Well, then let's go back to these positive but decreasing marginal products. Well, this just then mean that we have this form of production function if we just draw this in a diagram. Because here you then just see, let's increase from 1 to 2 the input of L, of labor. Then this would be delta y1, your increase. And then you have this right-banded shape, because why? We want to have that the increase is decreasing. And let's say here we are going from 7 to 8. The 8th guy is hired, and then of course the increase is less. So delta y2 is smaller than delta y1. So this means then the increase is decreasing. So of course this function is monotonically increasing. So we have dy at the first derivative with respect to L is larger than 0. We have this increase, and from this we have dy 2 with respect to dl square is less than 0. Well, and with these assumptions, now I already started with this calculation. Now we can derive the demand for capital and the demand for labor. And now here we in general want to deal with the demand for labor, because we assume that in general our production side is defined by the labor market. Or the labor market is the most important input for our production. Labor is assumed to be the most important part of production. Well, this I did already. Profits, revenue, and costs. Taking the first derivative in order to maximize profits means then here prices times marginal product equals interest rates for capital, and of course price times marginal product equals wages and this in general then means that you always have, if you have fully competitive markets, that in optimum marginal product equals real input prices. And this condition for optimum condition for optimal profits, you please keep in mind going on in your studies. Well, and then we take this condition here, this is nothing else than this here, and now we take the assumption that the second derivative of the marginal product is less than 0. Because then you know this is a decreasing function. And then in general we assume that we can decreasing function in L. That you can take just the inverse of this condition, so the inverse of this marginal function. But if a function is decreasing, then also the inverse is decreasing. So from this condition, we can, by taking the inverse, derive the labor demand depending on real wages. But since this is a decreasing function in L, we can derive that the demand also is negatively dependent on real wages. And this then means that we obtain this classical picture that you have a falling demand function. Falling demand in prices, and prices are, in our case, if we look at the labor market, real wages. Or I think you have seen this picture also in other lectures. If you want to derive this in this graphically, then we take just This is output minus real costs, and output we derived that this is the right-banded function, so the blue one. Real costs, depending on the input factor, is just a linear line coming from the origin. And if you want to maximize profits, then of course you look where is the largest distance between the output and the real costs. So given this first real wage, omega 1, omega is W over P, then this would your labor demand, depending on omega 1. And if we now increase omega 1, or looking at constant prices, increase nominal wages W, then your linear line just turns to the left, because we assume omega 2 is larger than omega 1. And what does this mean? That just this point where the distance between the blue line and the now red line, the new line for real costs, moves to the left. And for this you have a graphical representation or derivation for this falling labor demand in prices. Here, real wages. You have seen this graphical derivations for optimal, in order to maximize profits, because then you always look here at the tangent, that in this case, in this point, always the slope of the blue line and the slope of the cost line have to be the same. Well, then you have seen it here. Okay, when we have labor demand, of course, we also need labor supply. Well, who are the suppliers of labor? This is you. You are the suppliers of labor. In 1, 2, or 3 years, I don't know, maybe you also want to make a master, then in 4 years, then you are going to the labor market and you then supply your time to work. And what is behind your decision? How many hours I want to work for a given wage? There we assume that this is a decision for you between working and having spare time. So what we assume is that you have preferences, utility function, depending on C. C is of course consumption, and F is spare time. And we think, of course, that the more the better. That this functions, of course, exhibits the assumption, the more the better. The higher my consume level, the happier am I. The more time I have to go to holidays, the happier am I. But then there's one problem, because I need money to consume. And where do I get the money? I get the money from working. So if I want to consume, I have to work. But if I have to work, I could not go to holidays. And this is the connection between consumption and the spare time. Because we think that my total labor income this total income I spend for total consumption P times C. Well, and then what is my general restriction? Well, I could not work more than 1 day a day. And this connects now my working time, L, with my spare time or my free time, F. Because, of course, we think that L bar, for example, 1 day equals the time I work plus the time I go to holidays. And let's now take these two conditions together. So then we also have L is L bar minus F. Okay? And this we put now in the budget restriction. Then we have PC equals W times L bar minus F. Then we multiply the bracket. W times L bar minus W times F. Plus WF means PC plus WF equals WL bar. In a minute you will see why I do all these calculations. Now we divide by P, and then we have 1 times C plus W over P. Remember, these are real wages, equals W over P times L bar. So what is now our maximization problem? Our maximization problem is now maximize, here F is missing, U of CF subject to 1 plus C plus W over P times F equals W over P times L bar. And I hope that you now already see that you have done already something similar. And maybe if I change now just the variables, you will see that this is definitely the same what you have done, I think, half a semester. Because we are in fully competitive markets, prices I have to take as given, and L bar, my 1 day or my 1 month, my time restriction is also given. It's just a number. So this is real wages times my time restriction is just a number. And this I call now M. This is just, I can define this as M. There's nothing theoretically meaning behind this. This I call P2. This I call X2. C I call X1. And 1 I call P1. And then I have here x1 and x2. And this would mean just interchanging the names of my variables. This is max of u of x1, x2 subject to m equals p1 x1 plus p2 x2. You have seen this already? Then you can solve this with the Lagrange, but this is just the household optimization problem. You can do it, yeah? We will do it now graphically. Household optimization problem. So it is totally equivalent. How did you do graphically the household optimization problem? Well, at first you looked at the restriction, the budget restriction. And the budget restriction now is, in our case, this is our budget, divided by the prices is just the intersection with the horizontal and the vertical line. So if we write down this budget restriction, then for C, we obtain here W over P times L bar. For F, we have to divide this by the price of F. The price of F is real wages, so real wages just cancel. Of course, if we only go to a holiday, then we cannot work anymore. So this is our restriction. And what have you then done? Drawn to obtain the household optimum? Indifference curves? What have you now in order to obtain the optimum of the household? What do we need? The indifference curve. And how does a difference curve looks like? Yes. Well, and we want to move these indifference curve as far as possible to the upper right. So, in optimum, we would have somewhere here the optimal indifference curve, and this is then the optimal point for labor supply, because here we have then F star, this would be our C star, as you had it also as x1 and x2, but F star connected with L bar is nothing else than 1 minus L star, so we obtain L star equals 1 minus F star, and this is then our labor supply. So, and now this we will do today before we stop. Now increase wages. What happens? If V over P is increasing. What happens then in our picture? Which curves are changing? Well, we just have to have, yeah? Yes, great, because only here we have the real wage, and if this is just a larger number, here L bar, the 1 day is still 1 day, but this moves then upwards here. Great, so we rotate our restriction upwards. This would be then omega over P prime times L, for example. And what then happens? Yep. Mm-hmm. Mm-hmm. You really formulated in a good way. We may be, because the only thing, because preferences are totally individual, I cannot say what you have to have for preferences. You are absolutely free. The only thing which we make is the assumption: the more the better. The convex assumption, and what else we have? Transitivity and so on. And in general, this means that the new indifference curve, if we have now here more spare time, more free time, and more consumption possibilities, that we are somewhere on the upper right, but only somewhere. So this is possible, but this is also possible. Both indifference curve would be on the upper right compared to the former difference curve. Both new optima are possible. But well, here free time is increasing, and in this case free time is decreasing. So, and maybe you also have done this in microeconomics. Well, one argumentation that this is decreasing, that the higher the wages, the more I will work. The other argumentation is just, well, if I increase my time to work, then I can even more consume. And this would be maybe the first argumentation we have in mind. If the company says to me, well, you are not getting 20 hours, 20 euros per hour, but 25 euros per hour, well, then I say, great, well, I will work 1 hour more. But you are free in your decision, so you can also say that you think, well, I'm working for 2,500 euros per month, maybe with 20 euros per hour, and that you are quite content with your labor income, with these 2,500 euros per month. And now wages are increasing from 20 to 25 euros per hour. What does this mean? This means that you can earn your 2,500 euros per month with less time. And so from this argumentation, you would have an incentive to decrease your working time because you say, well, I don't need more money. And then for this is the so-called substitution effect. There you substitute free time with consumption, and this is the income effect. There you say, well, I'm already content with my income, I don't need more money. Now with higher wages, it is possible to earn this income with less time, so I reduce my working time. And which is greater, larger? Well, this depends on you. This we don't know. Here I wrote everything also a bit more theoretically, but I think the graphical derivation is more intuitively. But then we can have a look at the income distribution in an economy. And how does number look like an income distribution in an economy? Well, this would mean we have more medium or, so to speak, poor people than very rich. This here are rich people. And here will be the median. This is in Germany. Roughly 40,000 euros per year. Well, and this is an assumption we made. Then we say the people with the median or average income, or the people who are poor, they will in general increase their working time when wages are increasing. And very rich people, there we can say, well, they are so rich, why should they work more? That in this part, maybe here, the income effect would be larger. But we see from data and also from the general argumentation that median or poor people and the number of these people is much higher in a society as the number of the rich people, that we then say that in general we assume that the substitution effect is larger than the income effect. So SE larger than the income effect as an assumption in a developed economy. Well, and then from this argumentation, we have this plus sign, and putting this together, we then have increasing labor supply and decreasing labor demand. This defines our equilibrium amount of labor in our society, in our economy, and we assume that production, as I mentioned before, is mainly determined by the labor market. So this level here then also defines mainly total production. And with this, today I will stop, and then in general we are dealing in next week on Tuesday, because on Thursday we have the talk from the Bundesbank with the general equilibrium. Okay, thank you very much for today.